Hello, scholars. In today's lesson, we're going to learn how to convert measurements in both metric and customary. And these measurements that we're going to be working on are inside of word problems. And we're going to use our word problem steps of cubes to analyze these word problems. So the first thing we have to do is read the word problem. Madison had 14 kilograms of pineapples. How many grams of pineapples did she have? So we're going to circle our key numbers, and the only key number we have is 14. Oh, but we do have to include the unit of measurement, which is kilograms. And we see that it's asking how many grams. So the question we have to underline. So let's underline this question. How many grams of pineapples did she have? Now we have to box any math action words and write the operational sign. Well, we're not too sure exactly what we have to do, and there are no math action words in this word problem. So now we have to eliminate and get rid of unnecessary information. In this, there really isn't any unnecessary information. So let's evaluate and draw. So the first thing we have is Madison. Here's Madison, and she has 14 kilograms of pineapples. That's a lot of pineapples. And we have to figure out how many grams that is. 14 kilograms to grams. So let's look at this first chart, the King Henry slider. Kilograms is here, and grams is here. So it says here, divide by 10 each hop to the left. Well, we're not moving from grams to kilograms, we're moving from kilograms to grams. So we're going to multiply by 10 each hop to the right. So we have 1, 2, 3 hops to the right to get to grams. So let's do that. We have 14 times 10. That gives us 140 grams. 140 hectograms. But we don't want hectograms, we want grams. So we're going to multiply this number by 10 because that's our next hop. So 140 times 10. That gives us 1,400. But that only gives us decagrams, not grams. So we have to multiply this number by 10. 1,400 times 10. And that gives us 14,000 grams. So to answer this question, how many grams of pineapples did she have? Madison had 14,000 grams of pineapples. Now this is kind of tedious, and there is an easier way. So let's look at this. On our King Henry slider, this portion says moving decimal point to the right. So let's move a decimal point to the right. Let's try this. We have 14, and if we added a decimal point and some zeros out going this way, now let's try this moving our decimal point. We're going to move it 1, 2, and 3. And this is our new place for our decimal point. So let's write that number. 14 and a 0, another 0, and another 0, and that's where our decimal point would be. Now we don't need to worry about these zeros. They're just placeholders. But we do need to worry about these. So when we have 1, 2, 3, that's where we can put our comma to denote our thousands place. And we also find that using this method, we come to have 14,000 grams. Now there is another way to do it. Let's explore that one. Up top here on our metric conversion scale, we have 1 kilogram equals 1,000 grams. So another way to look at this is to take 1 gram and multiply it by 1,000, and that gives us 1,000 grams. Oop, I wrote that a little bit wrong. Grams. There's the comma. So if we do the same thing with 14 kilograms, we do 14 times 1,000. Now it's easier to put the larger number on top, so we'll go ahead and do that. 1,000 times 14. So we're going to go ahead and bring these zeros straight down, and then that's where our comma will be. Then we have 4 times 1 equals 4, and 1 times 1 equals 1. And we see that because 1 kilogram is equal to 1,000 grams, if we multiply 14 kilograms by 1,000, that gives us our amount of grams, 14,000 grams. And then we can answer this question. How many grams of pineapples did she have? Well, she had 14 kilograms, which equals 14,000 grams. Now let's try one in the customary set. We have our problem here. Michelle has 2,000 pounds of cookies to sell at the Girl Scout booth. How many ounces of cookies does she have to sell? Well, this is Michelle, and she's got 5 cookies here, and they don't look like they're 2,000 pounds worth of cookies. That's a lot of cookies. So we'll just imagine that part. Now let's use cubes to evaluate this word problem. Circle the key numbers. And with the key numbers, we have to keep their unit of measure as well. So we have one here, 2,000 pounds is one key word, or key number. And I don't see any other key numbers. So we're going to go to underline the question. Here's our question. How many ounces of cookies does she have to sell? Now we would box any math action words and write the operational sign. Once again, we're not sure about the operational sign yet, and there is no words in here that give us a hint to that. So we're going to go on to the next one. Eliminate and get rid of unnecessary information. Michelle has 2,000 pounds of cookies to sell at the Girl Scout booth. We can go ahead and get rid of all of that having to do with the Girl Scout booth and selling. And we can, how many ounces of cookies does she have to sell? We don't need the to sell down here either. So when we look at the problem again, it says Michelle has 2,000 pounds of cookies. How many ounces of cookies does she have? Now let's evaluate. 2,000 pounds to ounces. Using the customary system is a little bit more difficult than the metric system, but it's still possible. If we look here, we have 1 pound to 16 ounces. That's the same as writing 1 times 16. 1 would be our pound, which is represented by LB. If there's more than 1, it'll be LBS. Times 16 equals how many ounces 1 pound is, which will be 16 ounces. So if we use that same idea and replace the 1 with how many pounds we have, times 16, that will give us our ounces. Since this is such a large problem, let's go ahead and use the area model strategy to solve this. We'll put our 2,000 at the top. So we have one column for our thousands, another column for our hundreds, and we have nothing in our hundreds column, so we'll just put our zeros. Our tens column has zeros, and our ones column has zeros. Now let's move on to the 16. The 16 has a 1 in the tens place, so that'll be 10, and a 6 in the ones place, and that's 6. Now let's draw our grid so that we can work through this problem. And there we go. So 2,000 times 10. Let's annex this 0 and pull it back in over here. So if we write our 2,000 and multiply it by 10, we would bring that 0 back in and put it here. And we'll put a comma there to denote 20,000. And continuing this way, 10 times 0 is 0, and the same there, and the same there. Now we're down to 2,000 times 6. So let's annex these 3 zeros and only do 6 times 2. That equals 12. Now let's bring our zeros back out of annex, and we're left with 12,000. Now we need to add all of the, oh, I forgot to do this column. 6 times 0 is 0, 6 times 0 is 0, and 0. So now we have to add all of the numbers in the grid together. Since these all equal 0, we don't need to worry about those. So let's add 20,000 to 12,000. 0 plus 0 is 0, 0, and 0. We have 0 plus 2 is 2, and 2 plus 1 is 3. So that means that if she has 2,000 pounds of cookies, she has 32 ounces of cookies. So 2,000 pounds equals 32 ounces of cookies. So to answer this question, how many ounces of cookies does she have? Michelle has 32,000 ounces of cookies. And that's how you convert within the metric and the customary in word problems.